Hi, I'm Michael Gillett. I'm a solutions architect at Betway in London. And I've been with the company for a number of years, working from the front end all the way through to the back end on a number of the different websites and services that we offer around the world. In this presentation, I'm going to take a look at the ways in which over the last few years, we've really moved towards using testing in production as the way of doing releases, getting features out there, and how we are able to do more efficient testing. I'll also be sharing some of the tips and best practices that we've found over the past few years. So I'm going to share my screen and crack on. So what I want to make sure, just to set everyone's expectations, is that you don't expect this to be something where I'm going to give you a load of horror stories. So I'm going to give you this disclaimer. What we've got today is going to be about how you can avoid things that look like this, that look scary. There's nothing scary about testing in production, and sure, we've had a few things go wrong along the way, but that's what, towards the end of this, I'm going to be able to talk about the ways in which we've come up with ideas and processes to ensure that things don't go wrong, which is obviously what we all want. We want releases to go well. So the talk is going to be around how do we do testing in production, but it's obviously that element of how are we building things in a reliable way? How are we making things that work, that do the things that we want them to do, and do it in a way that won't give us headaches and problems as we're getting them out there? And I'm going to take a step back from talking about software, but look first in a wider picture, which is starting off with craft. And what I mean by this is how things used to be made several hundreds and thousands of years ago. This is how we did things. We dealt everything with a specific bespoke view. Everything was handmade. It was a craft to build pots and make anything was done in this very, very particular way. Quality was often there for sure, but it was a slow way of working. You couldn't scale it to the levels in which often we needed things. So it's quite inefficient, but it did often yield good quality things. That then led to, obviously, with the Industrial Revolution, we moved to mass production, where suddenly you can produce things in vast quantities, far faster than humans could make by hand. And we had loads and loads of things available to us. The problem, though, was that because everything was pretty cheap now to make, and you could make it quickly, things were made without really necessarily a need for them. Also, quality wasn't a concern. It was cheap to make this stuff, so they just made it. If 90% of every run through the factory was good enough, then that's fine. You just need to make a bit more and you've got what you needed. But obviously, that's not a very efficient way of working. And so that was refined into what perhaps is best known as Toyota doing, which was this kind of idea of lean mass production, where you don't want that element of waste. You want quality built into what you're doing. You don't want problems. You don't want quality issues. What you want is everything that comes out of that factory to be good. You want it to have that quality baked in. And the way that that was done was through understanding that pipeline, understanding the materials, the processes that were involved in producing these things. And through that understanding, constant refinement could be made. Hypotheses could be created as to better ways of working. And then the end goal was, well, you can validate whether that hypothesis was correct. And in doing so, bake that in for the next run through the pipeline or to the product that you're shipping at the end of it. All with fairly low risk, but it just means that what is produced results in very little waste throughout the process, and what rolls off that production floor at the end is of good quality. Then really what that is employing the scientific method in the way things worked. So moving from craft, treating everything in a bespoke way. Suddenly you want to do things frequently. You want to make lots of the same thing again and again. You can do that. You can't necessarily do it reliably. So then you bring in this idea of looking at the numbers, analyzing things, being able to test things, repeat things, draw conclusions. That leads you to lean mass production and an extremely efficient way of working. And obviously, we all get to benefit from that in our day-to-day lives with most of the stuff that we actually use. It's all adopting that lean mass production technique. And perhaps the best example of that is with NASA and getting humans on the moon. They started a decade struggling to get anything into orbit and finished the decade putting humans on the moon and bringing them back. That was not necessarily lean mass production, but it was the scientific method. What they wanted to do, they had an end goal, they had a hypothesis, can we get there? And everything that they did in that time was about constant improvement and refinement, collecting data, analyzing that data, and making sure that the next mission was more successful than the last. Wasn't to say that everything was successful. Sure, NASA had a lot of problems and some very expensive rockets blowing up along that course to get to the moon. But the point is they constantly refined, they constantly came up with ideas about improvements, they understood what it is they were dealing with, and through doing that, ensured they reached what they wanted to get to. And obviously we've got modern day equivalent with SpaceX. Only a couple of weeks ago they put humans into space, but here you can see they're landing 2 rockets side by side at the same time, which had never been done before. And again, just like NASA, SpaceX have had problems along the way. They've had rockets blow up and things go wrong and launches be scrubbed. But the point is, what they're doing is they're constantly learning from all of that stuff and improving it for the next time. But NASA and SpaceX are effectively doing this stuff in production. Yes, they are analyzing stuff ahead of time. They're running models. They're checking the data. They're checking that things all look good. But ultimately, when a rocket blows up because it's meant to be going into space with stuff,